If 12 ohm resistor draws a current of 1 ampere as shown in the figure, the value of resistance R is. I need to find the value of this resistance. This I can treat as ground, which means that this potential will be 0, right? So this potential will be 6, because if this is 0, this must be 6, right? This is 0, this is 6. Now if this is 0, this must be, since this current is 1 ampere and this is 12, 12 into 1 is 12, right? So this is 12 volts. Now 2 ampere flows in this direction. Out of that, 1 ampere flows in this direction. So the remaining one must flow like this, because I know by Kirchhoff's current law, total current entering a node, which is 2, must be equal to total current leaving the node, which must be 1 plus 1. So naturally this current must be 1. Now this potential is 12 and this potential is 6, which means that the potential drop across resistance will be 12 minus 6, which is 6 volts. So the potential drop across this particular resistance is 6 volts. So I know that R will be voltage divided by current, which means that the value of R must be 6. If VA minus VB is 6 volts, then VC minus VD is VA minus VB is 6 volts. I need to find VC minus VD. Now I do not know the values of these resistance values. But the thing is, VA minus VB is 6, which means that this current must be 3 amperes, right? Because 6 divided by 2 is 3 amperes. So 3 amperes flows in this direction. Now I just cut this part and make this two networks in such a way that I just cut this part and connect these two parts using a wire. So this is that piece of wire. So I know that this current is 3 amperes. So this is 3. I have two networks. One is this part, the other is this part, this one and this one. Now if 3 flows in this direction, I know that 3 must enter back into this network. 3 flows out of the network and 3 must flow back into this network. That is the way Kirchhoff's current law says. Whatever that goes out must come back. So if 3 flows in this direction, I know that 3 must come in this direction. So this current must be 3. Right? If 3 leaves, 3 must enter. Now if you want to have a clarification, if this is 3 and say if this is x, then this must be 3 minus x, right? This is x, this is 3 minus x. Now a part of that, I'll say this as y. So y flows in this direction, so this must be this will be 3 minus x. Y flows in this direction, so the remaining must be 3 minus x minus y, right? 3 comes in this direction, a part of that x flows in this direction, 3 minus x flows in this direction. Now again a part of that y flows in this direction. This is 3 minus x minus y. 3 minus x minus y flows like this. Now suddenly I get this y also. Now I get this x also, which means that the total current flowing out of this node will be 3 minus x minus y plus y for this one plus x for this one, which will be 3. So this will be 3. So this is 3 amperes. 3 amperes flows out and 3 amperes flows back into this network. Now at this particular node, this is 2 and this is 3, which means that together they will be adding up to make 5 volts. I mean 5 amperes. So 5 amperes flows in this direction from D to C, which means that VD minus VC, this is higher potential, because VD from higher potential to lower potential, 5 ampere flows, which means that VD minus VC, the potential drop will be 5 into 1. This is 5 volts. Right, VD minus VC is 5 volts, so VC minus VD must be minus 5 volts.